develop mechanisms where we apply artificial intelligence and big data to solve problems that are way too big for people. For example, understanding labor market. We can use data from job ads, job descriptions, economical news, different kind of future forecast reports like OECD or UNESCO reports. And based on that, we can let AI build an understanding what skills are needed, in what part of the world, in what industry. And I mean in real details. Not only that we need engineers, but we need engineers who can do this, and this. The skills in really granular, in really micro level. And this helps everyone, no matter if it is government, company, or individual, to make better decisions how we use the skills. For example, in this this slide, every block is one skill. One skill could be like, can do addition, can weld metal, can grind metal. So one block is one skill. What more the skill is needed, that deeper the color. And what more it is a core skill, that more it is in the center. And these maps helps decision makers to read what labor market really needs and what skills are related to others, because neighboring skills are neighboring. Of course, we can take time series like predictions. What skills are uptrending, what are downtrending, and basically go beyond why they are uptrending or downtrending. And this uptrending, downtrending is also important from education point of view, because really highly uptrending stuff is something we should pay attention, how we educate it. Downtrending doesn't necessarily mean we don't need to educate, but it is a place where professionals need to discuss how we deal with this. Time series are also interesting to see the change in some areas. For example, Washington DC, what is the difference from last year or last autumn to last winter? What has changed? Yellow are something that is already, that has been there all the time, and red skills are those that are disappeared. We don't know if there would be something that there is new, that would be green, but there is no green. I don't know if the Washington situation is because of Trump politics, but anyway, there are no that much new skills need, but only downtrending need. Then another interesting comparing is different cities, how they differ. For example, here we have Helsinki and Göteborg. Helsinki and Göteborg are pretty much the same size cities in Finland and in Stockholm. And how their skills seeking in software business is different. Once again, yellow skills are those that are common for both cities. Green is something that is searched after in Helsinki, but not in Göteborg. And red are something that is searched in Göteborg, but not in Helsinki. And it's really interesting to see that even two cities in Nordic countries, similar size, their skill seeking is that much different in software industry in general. And that's mainly because in Göteborg there is heavy industry like Volvo's factories and heavy industry, embedded systems and so on, while in Helsinki there is Nokia's legacy and strong startup ecosystem. And so the skill searching, seeking is completely different. And this is something we don't pay enough attention nowadays. Cities are different, cultures are different, so the demand is different. Now coming back to education. If we build exactly the same model based on course descriptions, in different countries the curriculum means different things, but I mean now the course descriptions. The descriptions where we say that in this course you learn this, this and this. If we slice it down like our labor market analytics, we can start to build pictures where we compare teaching versus labor market demand. And here we have, for one example where we have compared seeking in software industry compared to the local university's curriculum. Once again, yellow ones are those that are needed in labor market and also found in curriculum. Green one is something that is found from curriculum but not needed in labor market. But that's not a problem, because in quite many cases, labor market don't search for people who can do basic mathematics. But educational system must make sure everybody knows basic mathematics. So in that sense, it's place for discussion, not saying that they're doing bad work. But the interesting part is the red ones that are searched in labor market. So there is a demand, but no educational training. And there is the low-hanging fruit for educational institutes, no matter if they are public or private, but understanding what is needed right now. And in this example, we could point out just 5 to 7 courses on financial and business-related ICT, and the universities matched to labor market demand gets some 30% better. And this can't be done without understanding what is the real demand. Because way too often we think that demand is something that we ask from people from the street that, hey, what do you think somebody would need? And that's always wrong. We need big data to predict what really happens now. And when we take the science serious, we can try to predict a couple of years ahead. We can't predict what happens in 10 years, that's for sure. So we can maximum predict 2 years, I would say 1 year prediction, it's already good. But this is important from learning point of view. Okay, the next question is, when we find new courses that should be built, how we can do it? Of course, we can take them from Coursera, but we can use exactly the same predictive analytics model. But this time we let the AI read through, if we need a course about machine learning, we let AI read through machine learning journals and lecture notes, and it builds a mind map. So basically those are mind maps, or in terms of adaptive learning, knowledge graphs. Those are knowledge graphs about a certain topic. So now it's not building a mind map about labor market, it builds mind map about machine learning based on latest research and lectures. And based on that mind map, the same AI can show you not jobs, not courses, but for example content, news, or other content. Or it can generate tests on fly, because there is a mind map. Generation of automatized tests is really easy. And no risk that you get the same test twice, so you can't just learn by repeating the tests. You have to study. And finally, when we have a mind map, or let's say context, we have words familiar from labor markets, we can add learning analytics. Way too often learning analytics is just something that we report that this person has logged in 28 times, done 117 exercises, from which 70% are correct. And once again, this is pretty much nothing what comes to labor market qualifications. Well, what a person can do. But if we take a path, we understand the labor market demand and the words used in labor market. We can take the curriculum and put that in the same format, compare what part of curriculum is needed in the labor market. We can prepare, or let's say adjust, course descriptions and learning material suggestions to that same vocabulary, labor market, curriculum, course. We can also build learning analytics in the same system. Because now when we can test, however we test, is it multiple choice, or is it open-ended questions, or even some work. We can start to collect information how well you do one single skill. And I start a course, I do it, all I learn is recorded in this learning analytics, and it's immediately labor market compliant, because the vocabulary is the same, the definitions are the same. And we can place it in mobile apps, in conversational systems, of course traditional Moodles, but the idea is that when I'm going to work, we already know that what I know in green, what I have to study more in red. And that helps not only the person to focus on the stuff the person needs to learn, but also employer to arrange upskilling, continuous learning activities in order to make sure everybody do have optimal skills. And that's basically something we have to focus on. If we really want to train those 5 billion people with current resources, namely money and teachers, we need to understand what is needed, why, and we have to be able to track, we really train and educate the stuff needed in the work. And that's why we need AI, or let's say computational intelligence, because without it we would need some 1 million researchers to do it, and I would say that that's completely impossible. But future skills development is pretty much predictive analytics, and we need AI for that. But the predictive analytics and the ideas are applicable also in financials, like what kind of investments we should do and why, what kind of medical healthcare we should provide in what location and why. So the questions are pretty much the same, not depending on industry. But because we are in a startup event and the startup skills are essential for success, we need to understand what those skills are. And especially what those skills are in the areas we are competing against. What skills are needed in Finland, what skills are needed in Silicon Valley. You should have the same in order to be better. Thank you.
Thank you, Dr. Harri Ketamo. Mọi người có câu hỏi gì dành cho bác Harri không ạ?
Thank you. So I guess it's not very difficult for you to predict salaries in the labor market for the next couple of years. What is the accuracy? So is a Java developer, you can predict how much he or she will earn in Helsinki and Göteborg next 3 years, right? Where to move, where to relocate, right?
Yeah, the salary predictions are highly difficult. Not only because the salaries are really different in different locations of the world, but also because of different kind of cultural work-related things like how many hours you work, how the productivity is measured, how much there is tolerance on different kind of performance, because one Java programmer is not the same Java programmer, not even inside one company. But on average, if you want to make best out of now, focus on data science and Python. If you want to make best in the future, focus on data science and algorithmic thinking and be prepared to change the language.
Hello, I have one question. On the map you have shown, I recognize that when there's some red, green, yellow, but the difference in them, when maybe light red, dark red, not is any difference in here.
Yeah, thank you. Good.
Thank you.
I didn't explain them clearly enough. The idea of the depth of the color is that what deeper the color is, what deeper yellow, what deeper red, that more important such skill is in general. Doesn't mean that those light colored skills are not important, they are just, the demand is not that great. And of course in the very middle of the map there are skills like teamwork, responsibility, communication skills, sales orientation, marketing skills. No matter if we are looking after software development, the teamwork skills, customer orientation and such are essential in business anyway. So there is no software developer even without teamworking skills. And that's very important to understand. But the color basically means how much it is searched after. So what is the demand?
Mọi người còn câu hỏi gì nữa không ạ? Mình vẫn còn thời gian cho phần trình bày, phần hỏi và đáp này ạ. Yeah, okay. I think we can finish. Yeah.
Okay. Sorry, I thought that needed translation. My question is, do you differentiate between skills and competency? So we all know people who know a lot of stuff, but can they apply it across domains in unpredictable situations, etc.?
Very good. There is a lot of talk about competencies, macro competencies, micro competencies, knowledge, skills, attitudes, and so on. And this is really important to understand that they are partially always overlapping. If we think that, for example, teamworking skill, we can think that that's a competence and that's a transferable. Quite often we also discuss about soft skills and hard skills, but I think this is more for people, because for machine it's really difficult to understand when something is macro skill, what brings it micro skill, and when it turns to skill. So that's why in our modeling we let AI to read any labor market relevant work, no matter if it is teamwork or welding the metal. It deals them pretty much the same, even though we as a people understand that those are completely different skills. But if we try to do a definition that what is a competency, In fact, even United Nations and UNESCO, even though UNESCO is part of United Nations, they don't have similar definitions. And that ends up a question that what if we as a people can't agree on definitions? How we can expect that machine will learn something that is difficult for people as well? But I really love this topic, and I could talk 2 hours on this definition and teaching definitions to machine topic, but unfortunately we have to maybe go further with the schedule.
Just a quick question about how do you commercialize this knowledge? So who is the right client for you right now? What I would like to understand is what exactly the client pay for and how they do it. So it's a one kind of research, it's a continuous service, it's a monthly fee. So what is the details of the commercialization?
We have one, let's say, pipeline that we are covering here, but unfortunately there is no single customer on this full pipeline. So basically labor market analytics is something that governments, regional authorities and World Bank, for example, pays for, because that's strategic decision-making information for them. The curriculum and course analytics, so comparing our offering to labor market demand, is something that schools and educational institutes are paying because that makes them better. They can do more profitable work when they produce skills that are searched after in labor market. Then the adaptive learning and learning analytics part is something that both publishers and bigger educational institutes are paying because that ease up their work on recognizing what people have learned and is their labor market fit with something we have been teaching. So these are basically the paying customer segment. And of course, everything is designed for end user. So that makes our setting a bit complex. But basically, paying customers are governments, big educational institutes, and publishers.
Any more questions? Mọi người còn câu hỏi gì không ạ?
Xin chào quý ngài, tôi nghe ngài trình bày rất là dõng dạc và tình cảm. Tôi có một cái lời chia sẻ thế này, tức là với kinh nghiệm của ngài đi rất là nhiều nơi, trong đó có Việt Nam, thì ngài có thể có lời khuyên như thế nào đối với những người khởi nghiệp tại thành phố Đà Nẵng, đối với đất nước của ngài, và cũng như ngược lại ngài có kết nối như thế nào về đầu tư công nghệ nước ngài và nước Việt Nam mà riêng Đà Nẵng không? Xin cảm ơn ngài.
Yeah, thank you for the question. We have to always combine the local cultural stuff and global phenomena. And one suggestion is that, of course, we have to understand what is the skills demand globally, because we are in global competition, and how you can build a local, a cultural entity, or global phenomena, culturally different and strong, movement here. And I would say you shouldn't forget what happens in other parts of the world, because the data science, Python, they are high demand everywhere. And if you focus only on them, then there is not unique. But you have a very unique culture here. You have a very good background on science, maths. And then understanding a global demand, putting them together and building something unique enough, but still world-class. That's my advice. But we can't bring it outside, you have to find it yourself. But something that is culturally local, but still world-class, and understand where everyone else is right now.
Chúng ta vẫn còn thời gian cho một câu hỏi nữa ạ. Anyone want to have a question with Harri? Okay. Thank you, Harri, for your presentation. Can you have mọi người có thể có một tràng pháo tay cho bác Harri nữa ạ? Thank you so much.
Thank you.
Yeah. Đến với bài trình bày thứ hai trong buổi chiều ngày hôm nay, chúng tôi xin được phép giới thiệu ông Sara Benedict.